The next topic is number terms. So this is another area of study which has been done with regard to, again, the linguistic determinism and also the linguistic relativity. This is quite relevant to how the lexicon may influence thought processes. Now, thought processes with regard to mathematical abilities, how morphological differences in number names between Asian languages such as Chinese, Korean, etc., and English may influence children's conceptualization of numbers and ultimately their mathematics achievement. The research of Gordon in 2004 primarily focused on this particular aspect, and it was discovered that a person's numerical ability is influenced by a language he or she speaks. Gordon conducted this study on the Piraha language and the speakers of the Piraha language, and it was found that in their language they cannot basically count more than 4, because the numbers that they have, they are 1, 2, and many. So the study was later on re-examined, and it was further found out that these speakers, they do not have concept of exact amount, or they have different way of referring to large amount or great amount for that matter, as compared to the languages who have recursive number list. Now, based on this study, they come up with the idea that naming is more of cultural development rather linguistic development or universal linguistic phenomena. So now we will discuss some of these points with regard to number or numerical ability and how it is influenced by languages and how naming different objects or numbering is different in different cultures. Now, in English, the system of naming numbers is relatively complex. Now, the linguistic distinction here is not whether the different languages name numbers, but how they do so. The names for number 11 and 12, for instance, are unrelated to the names for 1 and 2. The names for 13 through 19 consist of unit name before the decade name, for example, 17. Furthermore, the names of numbers between 20 and 99 consist of the decade name followed by the unit name, for example, 33. In contrast to English system, Asian languages such as Chinese are more regular. Their names for numbers between 11 and 99 consist of the decade name followed by the unit name. For instance, the Chinese word for 18 is 10-8 and the word for 35 is 3-10-5. For number less than 10 and greater than 99, English and Chinese naming system are more familiar. The greater regularity of Asian languages suggests that children might have an easier time acquiring number names than their English-speaking counterparts. Some evidence indicates that this is the case, which is quite valid. Miura studies first-grade children from the United States and Japan. The children were shown how to use a set of base 10 blocks to represent numbers. The set consisted of white unit blocks and purple 10 blocks, equivalent to 10 unit blocks stuck together. On the first trial, the children were asked in their native language to read a number on a card and then to show that number in the blocks. After doing this for 5 minutes, they were given a second trial. They were reminded of the equivalence of 10 unit blocks and one 10 block and were then asked to show each number in another way. Miura distinguished basically 3 approaches to the task. One is canonical approach, which was one that placed no more than 9 unit blocks in the ones position, such as using 4 tens block and 2 unit blocks for 42. A non-canonical approach was one that was used some combination of tens blocks and more than 9 unit blocks, such as 3 tens blocks and 12 unit blocks for 42. Finally, a one-to-one collection used only unit blocks, such as 42 unit blocks. The results indicated that Japanese children were more than twice as likely as US children to use canonical approaches on the first trial. The US children tended to use one-to-one collections on the first trial. When they were to generate a second approach, the US children developed canonical approaches on the second trial. Miura also found that Japanese children used more non-canonical approaches than US children. Furthermore, as predicted from the analysis of the naming system, the range of numbers between 11 and 99 shows the greater differences. Chinese preschoolers are no better than American preschoolers at counting between 1 and 10 or beyond 99. But Chinese children are better at counting between 11 and 99 than their English-speaking counterpart. Additional work suggests that Chinese speakers pronounce numbers more quickly than English speakers, and that there is a correlation between speed of number pronunciation and mathematical performances. Now, the studies converge on the conclusion that the way these languages present numbers, all this process influences mathematical thinking. These studies basically concluded the way that languages represent numbers, the process does influences mathematical thinking. The language one learns play an important role in mathematics education. Miura stresses that the way one thinks about number is fundamentally different in Chinese versus English speakers.